One, I think, of the biggest problems that occurs in math is that words that are English words that you know mean different things in math than they do in English. So it's confusing because you have to learn a different meaning for a word you already knew. In discrete random variables, we're going to take apart and talk about discrete random and variable and what that means so that you'll know what a discrete random variable is. So discrete, all right, that's our first word, discrete. It means separate or unconnected. Yeah. So discrete means separate or unconnected. So if you were talking about things that are discrete versus things that are not discrete, individuals are discrete. Individual people are discrete. Anything actually, but then things that are not discrete would be things that run into one another. So like if you're filling a tub of water and you're measuring gallons, you don't have 1 gallon and then 2 gallons and then 3 gallons. It goes 1 gallon and then it fills slowly up to 2 gallons and then it fills slowly up to 3 gallons with all the ranges in between. So those are not discrete values. Again, discretes are separate things, whereas things that are not discrete can flow into each other. And you have a bunch of stuff in between that's occurring. Height. Height is not a discrete variable because you weren't 5 feet today and then instantly the next morning you woke up and you were 5'2". You gradually went from 5 feet to 5'2". Does that make sense? Okay. So in math, we're talking about discrete. We're talking about pieces of data that are not connected. Random in English means to lack any plan or be without a prearranged order. In math, that's not what it means. In math, random means an unpredictable outcome. So it's not that it's not planned, and it's not that it has no prearranged order. I mean, it kind of has no prearranged order. It's just we can't predict it. Random events are non-predictable. Okay, so then we have variable, which means likely to change or subject to variation. And in variable, it means it has no fixed value, which is kind of the same thing, likely to change. Okay. I don't know, anybody into astrology? Some people describe some of the signs as variable, meaning that they're changeable. The quickest one that comes to mind is Geminis get described as variable because they change a lot. I just thought I was trying to figure out another connection for you guys. Are values that are unconnected and can have variations within the values. So discrete variables. Unconnected variables that can have variation within the value. Random is that we cannot predict what those values will be. Okay, so if we went to the mall and we're walking through the parking lot and we're counting Fords. Okay? All right, so we're walking through the mall, we're counting Fords. The variable is the number of Fords we see. Because today there's going to be, 20 Fords. Tomorrow there could be 10 or 30. Right? It's not going to be that there's the exact same number of Fords at the mall every single day, or even in the morning as in the afternoon. So it's variable. It is discrete because you're a Ford or you're not a Ford. You don't go some in-between blending between a Ford and a Chevy, right? The car is a Ford or the car is not a Ford. Okay. Random is because of chance or probability. We could say that there's going to be more Fords during the day when the mall was open than there will be at night. We can when it's closed, we can calculate those probabilities as far as it's more probable during the day than it is at night when they're closed. But we cannot calculate the number of Fords that will be at the mall in the parking lot on any given day or time. That's random. We have no way of predicting that. So that's why counting Fords in a parking lot would be a discrete random variable. It's discrete because you're either Ford or you're not a Ford. It's random because we can't predict how many are going to be there. And it's variable because it's going to change from hour to hour, day to day. Does that make sense? Other examples of discrete random variables. We have how many people will answer a survey in a certain way. So if you've seen those survey takers that are on the street and you answer the survey. So how many people answer yes, how many people answer no on any given day. Discrete because you've got individual people giving individual answers. Random because we have no way to predict how many people are going to answer that way. And variable because it'll change from time to time. How many students walk to school in 8th grade each year? That's going to change every year. We have no way to predict it. We could kind of predict it based off of 7th grade, but still situations change, people move, so you really can't predict it exactly. The number of each color of jelly beans in a bag. They're supposed to be like proportionate. They're not. We all know they're not, because you always know that you have more of those ones that you don't like than any of the ones that you do like. Right? So the number of each color, so if you compared a bunch of different jelly bean bags, you'd get different results every time. Good? Okay, the probability of a discrete random variable can range from 0 to 1. Okay, if the probability equals 0, we are talking about an impossible event. It will not happen. Okay, the probability that I'm going to sprout wings and fly out that window in the next 5 minutes is 0. Okay, not going to happen. If the probability, I can't spell, oops, wrong button. Probability equals 1, then it will happen. Okay, the probability that I'm going to talk about probability some more is 1. It's going to happen. Okay, so with that, the closer you are to 0, the less likely the event. And then the closer you are to 1, the more likely the event. Okay, so when we look at the probability, again, between 0 and 1, 50 could go either way. Like 0.5 could happen, could not happen. It's exactly equal. Anything above 0.5 is more likely to happen. Anything below 0.5 is less likely to happen. Okay, so let's look at, first we're going to see which of these can be represented as a discrete random variable. The heights of the students in a high school. Height is growth, which means it flows into each other, right? So somebody's not exactly necessarily 5'1", and then instantly 5'2". You could have 5'1", 5'1.1", 0.2, 0.3, 0.4. The heights blend into each other. So this is not discrete. Does that make sense? Okay. Number of sit-ups that you can do, that's discrete. Sit-ups are individual. You're doing a sit-up or you're not doing a sit-up. You can't do, I guess you could theoretically say that you did part of a sit-up, but really you didn't do a sit-up. Okay, so you did a sit-up or you didn't do a sit-up. It's discrete. The distances between stars and a galaxy, not discrete, because distance can be any infinite number of values flowing into each other, right? Just sort of like height. No, not. I said not, I wrote is. Yes, not. It's not discrete. Okay. Wins by professional hockey team. We're counting up wins, right? So it's discrete because you won or you didn't win. So this is discrete. Speed of car in a race. Not discrete. Okay, think of it this way. If it's an integer value and you can only have an integer value, it will be discrete for sure. If it can have fractions or decimals, chances are it's not discrete. You'll want to analyze it a little bit more just to make sure, because if it's going in, like let's say you can buy a pound or a half-pound increments, so you can only have a pound and a half, 2 pounds, 2.5 pounds, something like that, then it would still be discrete even though it had fractions in it, because there wouldn't be anything between the pound and a half, if that makes sense. But then if it's like you're buying rice and you're measuring out rice into a weight, you know, like 1 grain, 2 grains, 3 grains is going to make very slight differences in the weight. So that would not be discrete. So if it's an integer value and it can only be an integer, it's definitely discrete. If it's got fractions or decimals, it's most likely not discrete. But you want to do a little bit more looking and thinking about it. Does that make sense? Yes? No? Okay. All right. Okay. It is very likely, but not certain. Not certain means it's not 1. That the high temperature will exceed 75 degrees every day next week. Suppose that the discrete random variable x represents the number of days. Okay, temperature is not a discrete value because it can flow into each other. But days, number of days, is discrete. So we're saying that the discrete random variable is the number of days next week that the high temperature exceeds 75 degrees. We want to know what is the probability that it's all 7. Okay, again, it's very likely but not certain. That means we can't have E. It's very likely, so it's definitely not impossible. 5 is our halfway point. Could go either way. Anything less than 5 is not as likely. Very likely is closer to 1. So our answer is D. Does that make sense? So, not at all. Probability is 0. Definitely. I can't spell definitely. Certain. Probability is 1. 50-50. Probability is 0.5. In here we have various stages of likely, and in here we have various stages of not likely. It is, kind of. All right, so let's say x is our discrete random variable, and it represents the number of points out of 100 that Royce scores on a test. If the probability that he's going to get a 42 is 88%, which do you think is true? that he's going to do well on the test. He doesn't know a single correct answer on the test. That would be a 0% score. He didn't study much for the test. He knows all of the correct answers, or he studied a lot. Okay, the probability, yeah, we want to make sure we read this. This is the probability. It's an 88% chance he gets a 42. 42 is bad, right? We all agree that. So that's, yes, it's C. He didn't study much for the test. That's the statement we can make from that information. Put these in order from least likely to most likely. Okay, we have, if a die is rolled 2 times, the same number will come up each time. Well, the probability of that is 1 out of 6. Because we're talking about the second roll. Christmas will be in December next year. Okay, the probability of this is 100%. That is going to happen. Christmas is in December, correct? We all agree? Yeah. It's not going to change? Okay. It could. Okay, a letter chosen at random from the alphabet will be a consonant. So A-E-I-O-U, that's 5 out of 26, 5 vowels. So we have a 21 out of 26, which, let me calculate the percentage on that so we can compare it easier, is a 0.81%. Okay? Or it's 81%, not 0.81. If a couple has a baby, it will be a girl. Yeah, 50-50, right? 1 out of 2. And a population of Wyoming will be greater than California in 10 years. Now, I do not have an exact probability of that, but the population of Wyoming is currently around 600,000 people. California is currently around 37 million people. What do you think the probability is? Yeah, that Wyoming is suddenly going to eclipse California in 10 years. So we're going to say the probability is 0, or at least close to. If you didn't live anywhere near the ocean, so he's not likely to fall off. But that's the only way the population of Wyoming would be greater than California, is if California fell off into the ocean. Or the levels of the sea rose. Then Wyoming would have a higher population, but that's not likely to happen in 10 years. So, probabilities, we have a 0. Oh, E, sorry, E is our 0. Followed by our 1/6. Okay. Followed by our 1/2. Followed by our 0.8. And then our 100% chance of Christmas being in December. So least likely to most likely. With the probability distribution, it is a semi-visual representation of the probabilities. So we have a chart, a graph, a table, and it shows you all of the possible values of x and all of the probabilities of those existing. Okay. Obviously, when we have infinite values, you can't put that on a graph. So it's always a finite set of things. You can't have an infinite set and do the probabilities of that. Okay. Discrete random variables are not mutually inclusive. They're discrete, right? So 2 things, you can't have something be both things. It's one or the other. So it's not like where you talked about a red 7 where you'd have like a red and a 7. They're both at the same time. It's not like that. It's one thing or it's another thing. That's it. So we are going to toss 2 coins, and I'm going to show you the probability distribution in a table. Okay, so table. Here what I have is the toss number. Now I'm going to toss 2 coins, so I have each toss I get 2. Okay, so I have a first toss, second toss, third toss, fourth toss. And then I have the first coin, and then the second coin. Okay. So when I toss the first time, I can get a head and a head. I can get a head and a tail. I can get a tail and a tail, or I can get a tail and a head on my coin tosses. Does that make sense? Those are the possible outcomes when I take 2 coins and I toss them. I get 2 heads. The first coin is a head, the second coin is a tail. I get 2 tails. First coin is a tail, the second coin is a head. Yeah.
Is there really a difference between tails and heads and tails?
Yes. Not in the numbers necessarily, but in that we're counting the coins as separate. So heads from the first coin, tails for the second is different than tails from the first coin, heads from the second. In our counting, not in maybe necessarily physical reality, if that makes sense. Okay. So let's call X the number of tails. Just to call it something. It can be the number of heads or the number of tails. We're just going to call it the number of tails. In our first chance, we have a 0 number of tails. Here we have 1 tail, 2 tails, 1 tail. Okay? So our probability of X, so our probability of tails, hold on. We have a 1/4 chance of this happening where I get no tails, because 1 out of 4 tosses. I have a 1 out of 4 of getting a head then tails, a 1 out of 4 of getting a tails and then tails, and a 1 out of 4 of getting tails and then heads. All together they add up to 1. Does that make sense? So our chances of this happening to where we get 0 tails is 1 out of 4, because there's 4 different scenarios. Okay? Because 2 tails happens in 1 of 4 scenarios.
Oh, okay.
Does that make sense?
Yeah.
So that's why each of these is 1/4, because this can only happen in 1 out of 4 of the scenarios. This happens in 1 out of 4, 1 out of 4, 1 out of 4. Now, if you said, what is the probability of 1 tail? Without specifying whether it was the first or the second, it's going to be 2 out of 4, which is 1/2. Because I get it, or sorry, 3 out of 4. Because I get a tail here, I get at least 1 tail here, and I get a tail there. So the probability of at least 1 tail is 3 out of 4. Okay, but the probability of each of these scenarios is 1 out of 4. Okay. The probability of only 1 tail would be 2 out of 4. So this is at least. If I did the probability of only 1 tail, that would be 2 out of 4, or 1/2. Okay, does that make sense? So we just add them together for the different scenarios. All right, so we're going to represent the probability distribution from example A graphically. Okay, so give me a second to draw. All right, what I have here is my probability of no tails at all was 25%, because it was 1 out of 4. Okay. My probability of 1 tail, that happened twice, right? 1 tail here and 1 tail here, so that gives me 2 out of 4, or 50%. So my probability of 2 tails is 0.5. I mean, probability of 1 tail is 0.5 because it happens twice. And then my probability of 2 tails, again, 2 tails only occurs once, So I'm at 0.25. So that is a probability distribution represented graphically. So you look at this, and this is, okay, well, it's most likely to happen to where I get one tail. The probability distribution for heads would look exactly the same because there's only two options, so it would look exactly the same. It didn't really matter if we picked heads or tails. First of all, does this represent a probability distribution for a discrete random variable? There's colons in here, but they should be decimals, so sorry about that. Probability distribution for discrete random variable adds up to 1. So in order for it to be a probability distribution for discrete random variables, all of your probabilities have to add up to 1. So I have 0.1 plus 0.2 plus 0.3 plus 0.4. So that's 0.3 plus 0.3 is 0.6 plus 0.4 is 1. So yes, it does represent a probability distribution. If it adds up to anything other than 1, the answer is no. Okay, so those shouldn't be too difficult. All right, so we're going to spin a spinner 3 times. And we're going to calculate the probabilities. We have red and blue. Okay. Here's how you figure out how many rows you have to go down. Okay, we're doing 3 spins, so I know I have to go 3 across at least, but I need to know how many I need to go down. That tells me how many different options there are. I'm going to start with red. I can get 3 reds. I can get 2 reds and a blue. I can get a red, a blue, and a red, or I can get a red and 2 blues. Those are my options if red is first. Does that make sense? Then I have to do blue first. And I can get 3 blues. I can get 2 blues and a red. I can get a blue, a red, and a blue, or I can get a blue and 2 reds. So it's combinations. If we were doing a 4th spin, we would keep going because we would have had more reds and more blues. So you just, to know how many to go down, you just start with one thing. And when you've eliminated all the possibilities from that being the first one, then you pick the next one to be the first one and create all those possibilities. Did that make sense? Okay. Now, if we call X, let's just say X is red. It really doesn't matter. X could be blue, but I'm just going to call X red. Okay, in this scenario, I have 3 reds. Here I have 2 reds. Here I have 2 reds. Here I have 1 red. Here I have no reds. 1 red, 1 red, 2 reds. So far, okay? My probability of any of these things occurring, I have 8 total possible, because that's how many combinations I ended up with, were 8. So each combination probability is going to be 1 out of 8. Because this occurs 1 out of all 8 times. Does that make sense? If I added all those up, I'd get a 1. Now, the probability distribution, the probability of a 0, 0 occurs 1 out of 8 times. So that's 1/8. The probability that I get 1 red, I have 1, 2, 3 ones. So 3 out of 8 times I get 1 red. The probability of 2 reds, 1, 2, 3. So the probability of 2 reds is also 3 over 8. And then the probability of 3 reds only occurs once. 1 out of 8. And then to verify that this is in fact a correct probability distribution, if I were to add those up, they should still equals 1. And that's another way to check to make sure you got your numbers right. They'll have to add up to 1. Does that make sense?